welcome to the session. Greeting of the day. In today's class we are going to talk about hydraulic systems. In the actuating systems, as mentioned earlier, we have the electrical actuating systems, pneumatic actuating systems and hydraulic actuating systems. On that now we are going to see about hydraulic systems. In the previous class we have given an introductory part of what are the components available in the entire hydraulic systems. On specific, there now we are going to talk about the hydraulic pumps. We are going to talk about the hydraulic pumps. A combination of pumping which gives a driving motor unit is known as a hydraulic pump. The usage of hydraulic pump is to pump the fluid to the control unit in such a way from the control unit it goes to the tank or to the piston to operate. It means actuating to be done. We have seen this diagram earlier cases. So this diagram we have done from the tank to the pump, from the pump to the regulator and control, and from the control we have to come inside, whether to be pushed weight operating to be downward direction or to be operated to the upward direction. This control unit will do. We are here to discuss about what are the various types of pumps are available. In such a way the volume of the fluid can be pumped to operations. It means to actuate. So here it draws a hydraulic fluid. Mostly we are using the oil from the storage tank as mentioned, from the storage tank, and delivers into the rest of the hydraulic circuits. What is this rest of the hydraulic circuit? It is nothing but the pressure regulators, the control units and the operating system. The speed of the pump is constant and the pump delivers an equal volume of oil in each revolutions of the pumping action. The hydraulic pumps are characterized into how fast the flow rate is done and with respect to power consumptions of the pump and with respect to the driving speed of and the pressure delivered. So with respect to this, we are characterizing this efficiency of the pump. The efficiency of the pump can be specified in two ways, of the volumetric efficiency and power efficiency. These things we have already seen about the centrifugal and the reciprocating pump. You see here the centrifugal force due to these actions of centrifugal action, when the fluid comes down, it will get the centrifugal actions which is from the center point, which is operated to the electric motor at the external. So due to this action, what happens in this, the fluid get the centrifugal force action and comes towards the outer ends. From here to here comes towards the outer end, it throws out from the center. The pipe, inlet pipes, which is the flow of fluid, comes to the center only. But from the center we are getting pressure. How we are converting this flow into pressure? By throwing outside. It is thrown to the outlet pipe here and we are taking out for the actuating of the piston as per the from the containers. So such cases we can able to do. So in the reciprocating pump we have kept the inlet and the outlet such a way crank machine operated, such a way when it is cranking is towards the one cycle, half cycle it will in and the second half cycle it will out. So this is about the reciprocating pump. Now the remaining part we have to see. Okay. The classification of hydraulic pump I am dividing as a non-positive displacement and positive displacement category. In the non-positive category we have, as we know, it is named as a hydrodynamic pumps. In this hydrodynamic pumps, the fluid pressurized by the rotation of the propeller from the center, which means it started to rotate, then the fluid pressurized occur and comes out, and therefore pressurized propeller and the fluid pressure is proportional to the rotor speed. How fast it is rotating, how fast it comes out. So that is related to how fast the fluid flow rate comes. So it cannot withstand this non-positive displacement. Pumps cannot withstand the high pressure and it is only suitable or used for low pressure applications and then high volume applications. So this is two applications we can able to use. The displacement, this is non-positive displacement pumps. When we are coming to the displacement pump, it can be useful for high pressures and the high volume. But here it is low pressure. This is important. Pressure is less, so weight can be, load can be very minimally operated. So such advantages are low initial cost, but low operating only. Less operating, maintenance also very less. So such a few advantages are there. Likewise, for example, we have seen the previously centrifugal pump, which is comes under this category of non-positive displacement pumps. And about the displacement pumps, we can able to create more volumes, more pressure. So deliver constant volume of fluid is generated here. At the discharge quantity per revolution is a fixed amount we can able to create. But in the centrifugal, you see how much volume comes out. We depend upon the force applied. But here it is not like that. Constant volume we can able to take exit and able to fix it. Therefore, the output flow rate is constant. Therefore, output flow rate is constant. So there we have written as a low pressure. Here I am written as a displacement, positive displacement. I am written here as a high pressure, high volumetric efficiency can be obtained in this positive displacement pumps. I can classify here into some three categories of gear pumps, Vane pumps and piston pumps. Now we are going to see about this various pump categories. Number one, we have taken as a gear pumps. It is a two measured gears or revolution about their respective axis. How we can go to the diagram, then we can able to understand clearly. So see, likewise. So I have taken a setup which contains two gears where it is operated in this. One is rotated at the clockwise direction, one is rotated at the anti-clockwise direction, and therefore the fluid flow comes from inside in this route. At the same time, it is also rotating, and therefore this tooth will come in this direction. It goes in this direction. Therefore, fluid will not flow in direct to the exit. But what happens? It occupies this space. It occupies this space. It occupies here. It occupies here. And then when it is going towards the other end, when rotating, that side it comes after one cycle of rotations, it takes the exit here. It takes the exit here. In such a way, we can able to monitor this fluid process, and same volume and increased pressure also possible to apply in the external gear pump method. It consists of externally measured two gears. It is measured over here. It is measured. This point is meshing point. This point location is a meshing point over two housed in a pump. One of the gear is coupled with the prime movers and is called as driving gears. Here, how this it is rotated. One I am connecting to the one gear. I am connected to the prime movers such as electric motors on the external side, and then one is operated by this tooth mechanisms. Therefore, one is operated by motors and one is operated by this internal tooth mechanisms. Therefore, one is a prime movers and is called as driving gear, and another is called as a driven gear. One is a driving gear, one is the driven gear. The rotating gears carries the fluid from a tank to the outlet pipe. The suction side is towards the portion whereas the gear teeth comes out of the meshing action. The clearance between the gear teeth and the housing between the inside plate and gear's face plays an important role. How fast this moves and how space it contains. This is the space which contains taking care of the volume of the fluid. So this is the space. So this is the space where it takes the volume. If it is rotating fast, it can pressurizedly come here and the flow rate will be high. When it is slowly rotating, the same volume comes slowly and with low pressure actions. So this is about the external gear pump. And now I am coming to the next one of the lobe pump. Here you can see it looks like a nutshell. Likewise, it is named here as a lobe. It looks like a lobe mechanism. So here, likewise, it is a tooth is 2. here is 1 and 2, and this contains second gear contains 1 and 2. Each gear contains 2 direction tooths are there. Here also, as like the similar pattern of external gear pumps, here also the fluid comes inside. Here also the fluid comes inside here, and then when it is rotating takes place in this direction. This is rotating in the clockwise direction, and this is rotating in the anti-clockwise direction. So what happens? You see, when it comes down, both here the direct path is not available. The direct flow path is not available. It flows in this direction, while during moving in this clockwise and anti-clockwise direction, the pressure is increased, and therefore when it comes out, a high pressure we are getting in this path. And next one, I am coming to the internal gear pump. What happens here? You see, here we have one more pump called internal gear pump. The multiple gears are there, which contains the flow rate of inlet coming in this direction, and then the outlet we are having in this upward direction. But we have one rotor component and one idler gear component here. Therefore, when the rotor is moving ahead, here the fluid comes here, occupies here. The rotation takes place in this direction. Anti-clockwise direction. When the fluid comes here, the fluid is taken here. When it is finding a gap to exit, with high pressure it is getting exited. So therefore, that is one of the easiest method, or you can have to increase the pressure of the fluid. This low or medium viscosity fluids such as solvents and fluid oils, wide range of temperatures are used here. It comprises of an internal gears and as a regular spur gears, and a crescent shaped seal and external housings are available. It is a birotational device. Whether this one can be used as an inlet, otherwise this one can be used as an inlet. In any direction, we can use the bidirectional inlet outlet can be utilized in this internal gear pumps. Reliable, simple to operate, and easy to maintenance also are some of the advantages of these internal gear pumps. And it is having the applications of in the variant fuel and oil industries, and in the polymer industries, alcohol and solvent industries, where we are using the fluid type objects or fluid types working environments, paints, inks, so such are available. We have a next Gerotor pump. I am dividing this as two cases. I am dividing into two cases of this, naming as a Gerotor rotor, and I am naming this as a Gerotor pump. See, a positive displacement pump, an internal gear pump without crescent. Earlier we have used this inside, a small crescent gear is used, but it is without, and it consists of two rotors, which is having one is at the inner and one is containing at the outer part. The inner rotor has n teeth and the outer rotor has the n plus 1 teeth. You see, the inner rotor has the n teeths. This is number 1, 2, 3 and 4. You see, we have, this is 1 and 2 and 3 and 4. This is inner rotor. So inner rotor having, let us consider for example, having 4 teeth. Now the outer rotor having number 1, number 2, you can write number 1, number 2, 3 and 4 and 5 are there. So what happens is this mechanism of attaching having the more and less configurations will come. First it giving the inlet here. It takes the inlet here and comes in, and it is pressurized here, and it goes taking the more volume of fluid in these zones. again it is want to come out here, the volume is reducing. See, these zones are getting reduction as compared to this large volume zone. This volume of fluid is compressed here and it is comes out, and therefore the pressure is increased for the same increased flow rate we would get. So this is another one of the this advantages contains, you see, this Gerotor advantages are having the high speed of rotation and then the constant discharge at all pressure conditions. We have seen this image having the two rotors, inner rotor and outer rotors. One is having the 4 tooth and one is having the N+1. So therefore we are able to have the high pressure conditions, and this is also the bidirectional operations are possible. In this also bidirections are possible. Less sound in the varying conditions. Fluid flow and other operations causes the less sound here. So these are some of the advantages of Gerotor pump. So limitations of clearance is fixed. Clearance is fixed and solid cannot be pumped out. Applications light fuel oils, lube oils, cooking oils and hydraulic fluids can be utilized. Next I am coming to the Vane pump. You see, as like previous one, we are using here a spring mechanism. A spring mechanism is used. Here I have the inlet, here I have the outlet as usual, but the pressure when it is rotating clockwise, when the large space comes, the volume of large space comes inside, this spring comes out and it projects here and it projects here like this, from center to like this direction it projects. Therefore here it occupies more volume of fluid. At the same time, when it is rotating like this, this point is going to extend. Then what happens? These fluids are here. The same volume fluid comes. The volume of the fluid is considered between these two. This two is one set of volume. This two is other set of volume. What we are receiving here up to this is one set. And what we are receiving the next one is that one set is going to take exit. So here we are taking the high volume, but the similar volume has to go, but where this spring is compressing, but where this fluid will go. Therefore this fluids itself compressed and getting the pressure, and it takes exit when it comes to the outlet point. So therefore we will receive the high pressurized fluid there. See, the leakage is reduced by using the spring load vanes placed in the slot of the driven rotor, and the easy maintenance and good suction characteristics are also possible. So applications in aerosols propellants, in aviation, servo fuel transfers, auto industries, fuels, loops, refrigerations and coolants we are using. Bulk transfers of LPG cylinders we are using this case of Vane pumps. So next one, I want to talk about unbalanced Vane pump. Very simple. See, as like all the pumps, we have the inlet and also the outlet, but here also I am using a spring mechanism. Likewise here we have one, here we have the red colors are belong to the springs. When this inlet comes, it occupies this volume. This having more a normal, this content it is occupying. This content is occupied. This content is occupied zone. See this volume. But the same when it is moving here, the space is getting reduced. This many big volume is converted. This many big volume is converted likewise. See, it is converted in this forward. And then later it is again further it is reduced. Again it is further getting reduced there. See, here it is again it is reduced. Finally it is how much from here, this means large volume of area to small volume it came. From there it is getting pressurized, compacted, and then it is taking the exit. So such way we can able to utilize this unbalanced Vane pump for pressurized oil flow or fluid flow rate. So these vane pumps have more than one vanes. Yes, it has the more than one vanes. The rotor is offset within the housing and the vanes are constrained by the cam rings as they cross inlet and outlet. Here we are using the cam rings to rotate. So vanes compresses to a large degree of for wear and the vane tips in the housing itself. Let's see, the next one we are going to talk about the unbalanced same. You can see this small clip where you can understand how this fluid flow takes place. And from one end it is receiving the blue color and then it goes down. The keep on pressure is increasing and it comes taking the exit. So such an easy method we can able to utilize. You see, an elliptical cam rings with the 2 inlet and 2 outlet portions are utilized here. What I am doing, some similar pattern of the spring mechanism we have taken, but for energizing I am doing this 2 inlet and 2 outlet I have taken. So this small, this blue color belongs to inlet. We have inlet maybe in this part, we have inlet maybe in the upper part. So 2 part I am having the inlet, therefore equally balanced output, balanced pressure output we will receive. So this blue color represents the inlet and the red color represents the outlet. But what happens there, we are getting normal to the high induced pressure outlets. Similar spring mechanisms of low volume, high volume to compressed volumes and pressurizing. This method is usually the same pattern I have used but with respect to 2 inlet and 2 outlet. So you see, an elliptical cam ring with the 2 inlet and outlets are used. The pressure loading still occurs in the vane, but 2 identical pumps halves created equal to these things. Opposite force on the rotors. It leads to 0 net force on the shaft and bearings. Therefore, lives of pump and bearings are increasing significantly. Also the sounds and vibrations decreases as we are distributing the forces. Lightly it is sounds are not there, so sounds or vibrations are decreasing. So such cases are possible by the balanced vane pump. See, adjustable vane pump, the same pattern we have used here. Such case of same spring mechanisms and inside and volume is reducing, pressure is increasing and comes out. Same method. So next the piston pump we are going to see about this piston pump. We have 2 cases of axial piston pump. We see here. In such cases, what I am doing, this is considered as an inlet, the upper part, and the downward part is considered as an outlet. I have a small driving shaft, a vertical inclined shaft. This inclined shaft I have connected to the inlet piston and outlet piston. You see, I have connected this to the inlet piston and outlet piston. When there is the inlet is coming here, when there is the inlet here, and when there is the inlet coming here, this piston moves outside. But the same shaft is connected, inclined to this outlet also. Therefore, when the fluid comes here, this piston moves out. At the same time, this piston moves again the other direction. So simple mechanisms we are using to inlet and outlet. So we are axial piston formations we are using here. The reciprocating action of the piston is obtained by bending the axis of the cylinder block. What I am doing here, I have just bended in this direction. A same state we have taken. Inlet, it moves. At the same time, reciprocating action takes place at the bottom also. Therefore, when it is inlet, other will get the outlet path. So very easiest axial piston operations are done. So this is also the same category. You see, the shaft is we are using the inlet, and at the same time we are using the outlet mechanism to do their respective processes. Finally, the radial piston pumps. The piston aligned radially in the cylindrical block. It consists of a pendle or cylinder barrels with the pistons and the rotor containing the reactions rings. So therefore you see very similar pattern as like spring mechanism we have done in the radial action. It is rotating. Center part is rotating in such a way the outer inlet and outlet, see the inlet is here, and after that it comes towards the outlet mechanisms. So here also the spring action takes place. The spring action takes place to create the same volume in the increased compacted way. So such things can be possible to make in the radial pistons. So the radial piston pump works on a high pressure of nearly about 1000 bars. The various hydraulic fluids like mineral oils, biodegradable oils, oil in the waters and water glycerin can be utilized in such a hydraulic pump mechanisms. So this hydraulic pump is connected to the regulator, and that regulator is connected to the control valve. That control valve controls where the fluid should reach. It is a simple pump which exits from the tank to the operation. But what the operations it does not know. It just pumps out the fluid. The control valve is there and it does the job where it should go, whether it should load or whether it should unload the system. So that things are considered as a total hydraulic configuration. It's connected to the computer and microprocessors through where it is going to be getting automated. So these are the various applications of radial piston pumps. The machine tools, displacement of cutting emulsions, high pressure units, test rings, automotive sectors we can use, and other powder injection molding processes, or we can able to use this in the various sectors. Application of hydraulic pumps. Transfer power via hydraulic liquids and automobiles, material handling systems, transmissions, fluid transmissions, lift systems, hydraulic lift mechanism systems are utilized by these hydraulic mechanisms. So the summary of this session, in today's class, in the actuating systems, we have seen about, there are three actuating systems. We know there are three parts: electrical, hydraulic and pneumatic. In this we are discussing about these hydraulic mechanisms. The hydraulic mechanism, here we have seen about some centrifugals and gear pumps. The remaining part of the subjects we will discuss in the next session. Thank you.